Hi, this is Naveen, and today we are going to conduct life cycle assessment of production of biochar from waste wood. In this video, we will be covering biochar in very brief with its features. Then we will be discussing how biochar is produced. For this tutorial, we have considered Kon-Tiki kiln technology, which is a kind of decentralized technology which is used in a rural area of our developing countries and even in developed countries too. Then very quickly we will cover the inventory details. That means the inventory which are used during production of biochar in the technology. And then we will be simulating it in Simapro. So if you are a researcher, academician from a sustainability field, then this video will save your quality valuable times. So let's start. Let's quickly cover what is biochar. So biochar is a carbon-rich material produced by heating biomass such as wood, waste, agro residue and other organic residue under controlled oxygen environment. And the process which is associated during the conversion of biomass into biochar is called pyrolysis. It is highly porous, lightweight and stable, which allows it to store carbon for long periods and improve soil quality. So it is basically used for soil quality enhancement. And biochar is called a net negative technology because it removes more carbon dioxide from the atmosphere than it emits during its production, which you'll see when you analyze the result in Simapro. Then you can appreciate why it is called net negative technology, or how much carbon it can mitigate when it is produced and applied field. And now let's see how it is produced in Kon-Tiki kiln. So let's understand how biochar is produced in very simple way. As you can see, Kon-Tiki kiln in the figure. So first we put wood, that is waste wood, into Kon-Tiki kiln and light fire from the top. Because fire is on the top, very little oxygen reaches at the lower layer. So instead of fully burning into ash, the wood slowly converts into biochar. Once the conversion is complete, we pour water to stop the burning or stop the fire. And that's it. Now we have a biochar. Now we will discuss how to conduct LCA step by step. As I have already explained in previous videos, and you must have some idea that LCA is normally conducted in 4 steps. That first you have to define goal and scope, system boundary, functional unit. Then you have to arrange inventory. Then you have to analyze inventory, and finally you have to interpret the result. So let's try to learn how to do this, and then we'll simulate the same thing in Simapro. From goal and scope. So goal of our this LCA study is to assess the environmental impact of biochar production from waste wood. And we have considered 1 kg of biochar as a functional unit. That means whatever the activities, scenarios, material inventory are used here that is applicable for the production of 1 kg of biochar. At the same time, whatever the result we will be analyzing, that will also be normalized per kg of biochar. That is a functional unit, and this is a simple meaning of functional unit here. In system boundary, we have considered, of course, we have considered this wood, then transportation of wood, and then this kiln or the material associated with this kiln, that is the steel and its fabrication, and then finally the final product, that biochar is packed here, that is packing material, and then it is transported to the endpoint. And besides it, we should consider the environmental burden associated during transportation of that kiln from manufacturer up to the site. As we have considered cradle to get boundary condition, that means we will not be considering its application phase or use phase. So now let's estimate the exact inventory which we may need to produce 1 kg of biochar. As you can see here, we need 400 kg of wood to produce 150 kg of biochar. That means to produce 1 kg of biochar, we need 2.6 kg of wood. So here I am not going to discuss the technical specification and details of the wood, that how much carbon content the wood has, or how much the moisture content it has. So I will not be discussing these technical details here, because our objective is to demonstrate these things in Simapro. So in brief, we need 2.6 kg of wood to produce 1 kg of biochar, which is our functional unit. Similarly, we may require around 50 kg of water to produce 150 kg of biochar. That means we may need 50 kg of water to lit the fire after burning. That means 0.33 liter is required to produce 1 kg of biochar. That is our functional unit. Similarly, we will be discussing the environmental burden associated with the transportation of raw material, that is feed material, that is wood from source up to the kiln, and transportation burden and environmental burden associated with the transportation of final product up to the endpoint. Okay, now let's explore how much raw material or how much steel we may need to manufacture that kiln. So let's suppose the kiln weight is 80 kg, and that data I have referred from a scientific study. I have included the link of the scientific study, and you may access that, take all the details, how they have assumed. So for our purpose, let's assume the weight of the kiln weight is 80 kg, and throughout its life period, it is used 500 times. That means in each batch, it will be producing 150 kg of biochar. That means environmental burden associated during the production of 1 kg of biochar only due to kiln is 80 divided by 500 and divided by 150. That means 0.00107 kg of steel. And if you go in the technical details of the material, then you will find that pig iron, that is used 90% of the total material. That means 0.00096 kg is contributed from pig iron. At the same time, that scrap material, scrap steel, is used 0.0001 kg. And let's discuss about the inventory associated during packing material. As you can see here, that one bag contains 150 kg, and that bag is reused 10 times. That means packing for that means the burden associated during packing of functional unit, that means packing of 1 kg of biochar, is this much. And this is the way we can normalize the inventory as per functional unit. And let's go to Simapro and explore suitable category, and then let's update step by step. So now let's go to Simapro. So first of all, let's create a new project naming biochar LCA. I have already created this project. Let me delete it and create it again. So let's create a new project, biochar LCA. And let's select all the libraries, because we never know which library we may need during our simulation. So let me select eco invent first, eco invent unit. Basically we'll be working on system, but anyway, let's select all. We have already selected methods. This is very important. We should not forget to select it, because without it we cannot analyze. So it is very important. And now let's go to product stage and update the database from this. and we will model it in product stage. In product stage, we will create a new assembly, that is biochar, let's say 1 kg, which is our functional unit. And then let's update each inventory step by step. So let's first update softwood. Material wood, where is wood? It's a 2.67 kg, 2.67 kg. Then update the second thing, water, that is process water. So let's try to explore the suitable category here. Water, so drinking water, market, let's select tap water, because normally tap water is used during production of biochar when it is produced locally. So let me select this one, tap water, and let's update the quantity, that is 0.33 kg. Next, now kiln material is steel, so you should explore first pig iron, then scrap steel. Pig iron, for simplification or for simplicity, we are just going to consider whole material as a steel only. We are not going to use a scrap metal here. So let's select pig iron and allocate all the resource to pig iron only. So pig iron, metal ferro is there, pig iron. Okay, pig iron, it may be suitable category for our purpose. It's the rest of the word that is so total 0.00107 and plus this plus this. So this is the way we can create any arithmetic expression also. This option is here. Now let's update another inventory. So now we have to update welding. So welding, we cannot find that category under material. It is within, I think, process. So we should update it in under process, and then we can go process and then processing, metal, and then welding. Let's consider welding, arc welding or steel. Arc welding for steel. Let's select system. And during manufacturing of that kiln, 0.00013 meter welding is associated. Then next category, transportation. So let's update transportation now. transportation, road, let's say market. We can consider any suitable category here. Let's say that things are transported by transport, freight, light commercial vehicle, diesel. So 0.107 is applicable for the transportation of kiln up to the site. This one, and plus this much is associated during wood transport from the source up to the site. All these quantities are already normalized as per functional unit. I don't know why it is not working. It's already working here. No issue. It's okay. So let me delete this. So we have almost updated most of the inventory. One thing is still remaining, that is packing. So the last inventory we have to upgrade is packaging. So let us consider the packet or bag is made of paper. So let's try to find the suitable category of paper, and we will not consider the processing of paper, or we will not consider the environmental burden associated during processing of paper into a bag to make our model simple. So let's try to update suitable category of paper here. Don't forget to click here, otherwise you cannot find a suitable category here. Waste paper, waste paper, for simplicity we are going to consider any category of paper. So for our purpose we are going to consider rosin size paper production. And let's update its quantity, which is 0.0067. So here unit of that bag, it's a in unit that is in piece, but for simplicity I have considered it as a weight. Basically we have to find the volume and then multiply with the density of the material, the paper material. So now we are going to analyze the environmental impact associated during production of 1 kg of biochar. So to do so, we should first click here at calculate, then we should click on analyze, then it is mandatory step, we must select any suitable method. I am selecting this one, Endpoint 2000 recipe 2016 Endpoint. You can select any suitable category as per your own requirement, and then let's click calculate, and then let's see. Okay, perfect. So now let's try to interpret the result, which is the final stage of LCA. As you can see here, it is in a network diagram. This is a network diagram. This is network diagram, and it provides us the overview of the inventory and activities associated during production of the final product. In our case, the final product is a biochar, that is 1 kg of biochar. So it means to produce 1 kg of biochar, we need that much amount of forest, soft wood, that much amount of water, that much amount of iron, and this much amount of paper for packing, and these are the processing activities which are associated during production of a 1 kg of biochar. Now let's explore environmental impact contributed by each inventory and activities associated during production of biochar. To do so, we should click here impact assessment, and this will provide us the category wise environmental impact. There are several categories of environmental impact. As you can see here, let's say global warming, human health, global warming, terrestrial ecosystem, acidification, eutrophication, ecotoxicity, and so on. So let's focus on the first category, that is global warming, human health, and let's try to analyze. It will provide us how to analyze the impact assessment. As you can see here, in global warming impact category, total environmental impact is 2.95 to the 10 to the power minus 7, and unit is carbon dioxide kg carbon dioxide equivalent. That means that much carbon dioxide equivalent is produced during production of a 1 kg of biochar. Out of this, softwood contributes this much, that is 1.59 into 10 to the power minus 7. Tap water contribute this much, pig iron contribute this much, and so on. Similarly, you can analyze other environmental impact category too. To visualize it, let's click here. This will provide us much clear picture than in the tabular form. So, for example, if you are talking about global warming potential, what we discussed just few seconds before, that green one, that is the contribution that impact is contributed by firewood. You can see it is a major contributor. Then second contributor is a transport freight, the transportation which we use to transport forest wood up to site and kiln after manufacturing, so from manufacturer up to the site. So this is the second largest contributor, and then third one, and then first one, second, then third one, that is the yellow one, and that is from contributed from paper. And in and the global warming potential of welding activity, it is negligible because you cannot see it in this bar. That means its contribution is very, very less. Now let's explore another impact category, that is damage assessment. So what is it? So in Endpoint recipe, damage assessment means that's a final impact on areas what we care about. So that is Endpoint, that means what is the actual final damage caused by environmental impact. So there are main three category in damage assessment, that is first one is human health, second one is ecosystem, and third one as resources. Here also you can see that much more health damage is due to firewood only, or that due to that softwood which is used here in production of biochar. And then second contributor is again transportation. So in overall we can say, from final damage assessment perspective, that wood and transportation are the major contributor. Similarly, if you are assessing the ecosystem damage, then we can conclude that much more damage is from softwood only. Others contribution is very, very less in ecosystem damage category, and so on. And this damage category is not available if you select another method, for example midpoint or other environmental impact assessment method. So let's see which type of category are available when we select midpoint instead of endpoint. So let's recalculate again. And let's select midpoint rather than endpoint. So endpoint, let me select this one, midpoint, and then let's analyze. So network no issue, you will get the same network what you had obtained when you had selected endpoint. Impact assessment category also you will find, here you can find different quantity, and here you will not find that damage, final damage assessment category. So the point here is, if you are analyzing or if you are assessing environmental impact from researcher perspective, then either you can select midpoint or endpoint. But if you have to focus, or if you are analyzing or if you are assessing that impact to recommend for from policy perspective, then you should select endpoint category. So at the starting of the video, I had mentioned somewhere that biochar is called, or biochar is considered as a net negative emission technology. So it means it can mitigate much more carbon than it produces during its manufacturing. As you can see here, around 0.286 kg carbon dioxide equivalent is emitted during production of 1 kg of biochar. And normally 1 kg of biochar can retain or can hold around 3 kg of carbon dioxide equivalent, although it depends on the carbon content, and we are not going into detail technical analysis. So let's just assume that if a 1 kg of biochar can retain 3.2 kg carbon dioxide equivalent in 100-year time period, and at the same time only 0.286 kg carbon dioxide equivalent is produced during its manufacturing, then very simple, simple arithmetic analysis suggests that around 2 kg carbon dioxide equivalent can be mitigated, and that is the reason it is considered as a net negative emission technology. So I hope you enjoyed this simple tutorial here. If you are interested towards such type of content, then kindly subscribe it and stay tuned. Thank you very much for your attention. See you in next video. Bye.